What if I told you Jupiter is packed with the most flammable element in the universe, yet you could never set it on fire? Sounds impossible, right? Jupiter is basically a gigantic ball of hydrogen, and hydrogen burns. So at first glance, the largest planet in our solar system looks like a cosmic bomb waiting for someone to strike a match. But here's the strange part. Even if you somehow flew across hundreds of millions of kilometers carrying a matchstick, nothing would happen. No explosion, no fireball, not even a spark. And that's where the mystery begins. Jupiter is so enormous that more than 1,300 Earths could fit inside it. Its mass is over 300 times greater than our planet's. Yet despite being made mostly of hydrogen, the fuel that powers stars, Jupiter has never burst into flames. Why? The answer hides inside one ingredient every fire desperately needs: oxygen. Without oxygen, fire simply cannot exist. Every flame you've ever seen, from a candle to a forest fire, depends on oxygen to keep the chemical reaction alive. And Jupiter has almost none. Its atmosphere is roughly 90% hydrogen and 10% helium, with tiny traces of methane and ammonia. But oxygen? Practically absent. Suddenly, the giant gas planet doesn't look like a bomb anymore. It looks like a trap. Because the thing that should make Jupiter incredibly dangerous is also the reason it refuses to burn. But that raises a much bigger question. If Jupiter can't ignite naturally, could we force it to? Could humanity build something powerful enough to overcome the oxygen problem and finally light the largest planet in our solar system? The answer sounds ridiculous. And that's exactly why it gets interesting. To ignite Jupiter, you'd need more than a normal match. You'd need to reinvent fire itself. A regular match works because friction converts red phosphorus into a highly reactive form that instantly combines with oxygen in the air. But Jupiter doesn't give you that luxury. No oxygen means no ignition. So what happens next changes everything. Instead of relying on Jupiter's atmosphere, your match would need to carry its own oxygen supply. Imagine a specially engineered match capable of generating oxygen through chemical reactions as it burns. Sounds clever. But here's the problem. Jupiter isn't a campfire. It's a planet. A very, very large planet. To burn hydrogen, you need oxygen in specific proportions. And Jupiter contains an almost unimaginable amount of hydrogen. Roughly 1.4 octillion kilograms of it. That's a number so large your brain almost refuses to process it. And this is where it gets weird. To combust all that hydrogen, you'd need oxygen weighing about 6 times more than Jupiter itself. 6 entire Jupiters made purely of oxygen. Let that sink in. The largest planet in the solar system would require an oxygen supply several times larger than itself just to begin burning. And here's the twist nobody expects. That much oxygen doesn't even exist anywhere in our solar system. Not on Earth. Not on Mars. Not inside the Sun. Nowhere. The fuel is there. The spark can be engineered. But the missing ingredient is so absurdly rare that the entire plan collapses before it even starts. At this point, Jupiter seems completely safe. Case closed. Right? Not quite. Because nature has already tested this theory for us. And the results were far stranger than anyone predicted. In 1994, Jupiter faced an impact that should have changed everything. A giant comet called Shoemaker-Levy 9 smashed directly into the gas giant. This wasn't a single rock. As Jupiter's gravity tore it apart, the comet split into massive fragments, some nearly a kilometer wide. Then they hit, one after another. The explosions were colossal. The energy released exceeded many nuclear detonations combined. Gigantic scars appeared in Jupiter's atmosphere. Shock waves raced across the planet. Astronomers watched in disbelief. And many wondered the same thing. Would this finally ignite Jupiter? After all, if a planet-sized match wasn't available, surely a cosmic collision powerful enough to shake an entire world would do the trick. But here's the shocking part. Nothing burned. Not a single planetary firestorm. Not one chain reaction. Not even the beginning of an ignition event. The impacts released tremendous energy, but energy alone wasn't enough. The oxygen problem remained unsolved. And that's the revelation that flips the entire story. Jupiter isn't protected because it lacks fuel. It has more fuel than almost anything else in the solar system. It's protected because the one ingredient required to unlock that fuel simply isn't there. The biggest potential fire in our cosmic neighborhood is permanently trapped behind an invisible chemical barrier. And that means Jupiter may be one of the safest giant hydrogen reservoirs imaginable. But that leaves one final mystery. If the solar system doesn't contain enough oxygen to ignite Jupiter, what kind of event would be powerful enough to change that? And if such an event ever happened, would Jupiter remain a planet or become something far more terrifying?